Okay, give me the quick list that you guys wrote down on the left-hand side of all the vocab words. What's the quick list? Just shout it out for me. Secant line, yeah. Secant line, diameter. Chord. Tangent. Center. Radius. And it's really looking terrible handwriting, huh? And what was the other one? Circle. There we go. That's much better handwriting. Okay, so look. 1, 2, 3, 4, 5, 6, 7 new vocab words, all right? Okay, so quickly, how would you describe, let's go in the order that you gave me. How would you describe the secant line?
A line intersects two parts of the triangle.
The triangle? The circle, right? So a line that goes through the circle twice, but not necessarily the center, right? Hey, relax. Okay, so that one right there. How would you describe the diameter? Yes, go ahead. It's a line segment that goes through the center. Beautifully put. Awesome. Nice job. How would you describe a chord? Hyro, how would you describe a chord? Goes from one side to the other without touching the middle. That's absolutely perfect. Nice job. How would you describe a tangent line? Mandy, how would you describe a tangent line? Only touches the outside of the circle one time. Nice job. That's our tangent line. How would we describe the center? Ooh. How would you describe the center? Oscar, what do you think, buddy?
If you put it down on just the center, it can balance.
Okay, so the balancing point, right? The midpoint of the diameter. Okay, there's lots of ways to describe the center. Nice job. How about the radius? What's the radius then?
1/2 of the diameter.
1/2 of the diameter. Good. And how about the circle itself? It's all of the points that are the same distance away from the center, right? And that distance is called the radius. Okay. All right, great. Let's talk about two types. There are two types of tangents that we're going to talk about here. Okay. Now that we have that, two types of tangents. Okay. There are external tangents. So type A, there are external tangents. And type B, there are internal tangents. Okay, so I challenge you guys right now to do one thing. And I would like you to draw two circles on the left-hand side, over here on the left-hand side. I want you to draw two circles that only intersect once. See? All right. All right, so many of you drew this circle, this picture first, right? Oh, yikes. Maybe you drew that picture first, right? Yeah. And then there's this one right here, right? You could draw the circle inside the other circle, right? Well, this describes both types of our tangents that we have here for circles, okay? There's an external tangent and there's an internal tangent, all right? So now, the way that I remember these is that the external tangent happens if the circles touch on the outside. So this could be an external tangent. Does that make sense? But you could also have an internal tangent. So two circles could be internally tangent if one circle's inside the other circle. So kind of like that. So it kind of tweaks your thinking, right? How many different ways can we have two circles be tangent to each other? They can be internal or external. And that picture describes both of those. Does that make sense to you? Okay, last idea here are these two theorems that we have. Okay, and we're going to talk about 10.1 and 10.2. Okay, so please give yourself a circle in 10.1, and let's call that circle P. So we're going to have our center, and we're going to call that circle P. Okay, from circle P, please draw yourself a radius to the edge and call that point Q. So now we have a radius PQ. And from there, we're going to draw a tangent line at Q and tangent to P. And we're going to call this line L. So here's the theorem that says right here. We got if L is tangent to circle P, then L is perpendicular to PQ, which means that it meets at a right angle. So here it is right here. Here's the important part. If L is tangent to circle P, then L is perpendicular to PQ, which means that they meet at right angles. And theorem 10.2 is the converse. Okay, what is the converse to my if-then statement? Here's my if part. Here's my then part. What's the converse? Yeah, Jared.
If L is perpendicular to PQ, then L is tangent.
You got it. You just got it right there. You hit it right on the head. He said if L is perpendicular to PQ, then L must be tangent to circle P. So is it okay if I just write converse there? Does everyone understand what I mean by that? Yeah. All right, good. All right, here's what I want to do. I want to do a little whiteboard activity with you guys. So go ahead and grab your whiteboards. And I'm going to show you a diagram. And what I want you to do is I want you to tell me what word is the piece of the diagram that I am highlighting. Okay, here's the first one. Where is the first one? Did I unplug it or something? Yeah. There we go. Oh, here we go. Okay. That piece that I have highlighted as quickly as you can with your partner, is that a chord, a secant line, a tangent line, a diameter, or a radius? No, try again. Good. Good. Show everybody in the room. There you go. What's that one? What is that one? Write it down. Show me as fast as you can. Good. Next one, what is that? Ooh, what is that one? Good. Talk to your partner. Good. Thank you, Daisy. Good. What is that? Good. Yes. Good. Thank you. Thank you, Manny. Thank you. Tangent line. Very good. All right, next one, ladies and gentlemen. What about that one? Ooh. Very good. What is that one? Good. Not the secant line. Good. Not a secant line. Good. It's a chord. Good. It's a chord. Why? Hold on. Why is this a chord? Because it's a line segment. Very good. Okay, what about that one? Ooh. Oh. Look at that one. Good. Good. Hey, nice job, you guys.